In September 2023, Storm Daniel precipitated an unprecedented collapse of two dams above the Libyan city of Derna. The resulting floods swept entire neighborhoods into the Mediterranean and left thousands dead or missing. Reports and satellite imagery showed a force of water moving rapidly down Wadi Derna, obliterating built areas that only hours before had been occupied. The official and humanitarian estimates of casualties varied as rescue and recovery continued, underlining how quickly a dam breach can become a catastrophe. A dam breach produces a different kind of flood from seasonal river rises. When an engineered reservoir fails, from overtopping, structural weakness, or an external trigger such as exceptional rainfall or seismic shaking, the release can be sudden and enormous. Hydraulic modeling and dam break studies show that a dam release flood wave can reach velocities and depths far beyond normal river stages. In steep terrain, the wave celerity, the speed at which the flood peak travels, can rise to dozens of kilometers per hour, giving little more than minutes for those downstream to react. Field and modeling studies explain why. The deeper and steeper the channel, the faster the flood front accelerates, and shallow water wave theory demonstrates that celerity increases with the square root of flow depth. In Derna, that mathematical principle became deadly reality. Within 30 minutes, the entire lower valley was gone. One local engineer told Libyan media that the pressure of accumulated rainfall had been beyond what any 1970s dam was designed for. "I saw cars being lifted like toys," one survivor recalled to Reuters. "And within seconds, there was nothing left, only water, houses breaking apart, and screams." Historical echoes. Disasters like Derna are not new, but climate change and aging infrastructure are amplifying their impact. In 1975, the Banqiao Dam collapse in China's Henan province remains one of the deadliest engineering disasters in history. Following days of torrential rain from Typhoon Nina, the dam burst, releasing an estimated 700 million cubic meters of water in just hours. More than 170,000 people died, according to later Chinese and UN assessments, and over 10 million were displaced. In 2018, a similar nightmare returned in Laos when the Zaipian Zainamnoi hydroelectric dam partially failed under heavy monsoon rains, flooding entire villages. Drone footage captured brown torrents sweeping homes off their foundations. Official figures confirmed 49 deaths and more than 6,000 missing, though unofficial counts were higher. Even countries with advanced monitoring systems have been caught off guard. In the United States, the 1976 Teton Dam failure in Idaho caused billions in losses. The Midwest floods of 1993 submerged an area larger than the state of South Carolina. In Europe, Germany's Ahr Valley floods, 2021, revealed that even early warning systems struggle to contend with extreme rainfall patterns accelerated by global warming. Each of these events, experts say, reveals a similar pattern: saturated ground, aging infrastructure, and a warming climate producing heavier rains. "We are entering a new hydrological era," said Dr. Petteri Talas, Secretary General of the World Meteorological Organization, WMO, in a 2024 briefing. Floods are becoming faster, deeper, and deadlier. Science behind the surge. According to the Intergovernmental Panel on Climate Change, IPCC, warmer air holds roughly 7% more moisture per degree Celsius, meaning storms are now capable of delivering far more rainfall than those a century ago. When that moisture releases, the result can be flash floods that rise within minutes. Hydrologists at NASA's Goddard Space Flight Center estimate that water from a broken dam or flash flood can climb 3 to 5 meters in less than 10 minutes in narrow valleys. At those rates, entire villages may be submerged before warnings can reach them. The U.S. Geological Survey, USGS, categorizes such rapid onset floods as catastrophic, often combining multiple triggers: intense rainfall, unstable slopes, and infrastructure collapse. Once in motion, the mass of water, mud, and debris behaves more like liquid concrete than a river, destroying everything in its path. On September 17th, the UN Office for the Coordination of Humanitarian Affairs cited 11,300 deaths and 10,100 missing in Derna alone. Aerial and ground photography revealed a staggering scene. Streets turned into rivers of mud, multi-story buildings washed away, cars flipped, rooftops peeking above rescue boats navigating through chaos. In images titled, "In Pictures, Libya Floods Wipe Out Quarter of City of Derna," Reuters displayed entire neighborhoods erased from the map, streets unrecognizable, with survivors perched on ruined balconies and submerged infrastructure. The disaster exposed more than just the raw force of water. It revealed how unmaintained infrastructure, climate extremes, and geographic vulnerability converge in the worst moments. An explanatory Reuters piece titled, "How Flooding Caused Devastation in Derna Laid Bare, How the Rains Filled a Normally Dry Riverbed, Overwhelmed Dams, and Unleashed a Deadly Torrent That Forced Structures into the Sea." Researchers later cited the Derna floods as a stark example of how dam design often underestimates compound risks, when more than one stress is applied. In this case, extreme rainfall, plus aging infrastructure and weak upkeep. Meanwhile, media coverage also traced political and societal fragilities. Libya's divided governance, outdated infrastructure, and limited early warning systems. In national headlines, local officials were blamed for negligence, and protests in Derna claimed that evacuation orders came too late. Subsequent legal investigations led to several officials being detained for mismanagement of water resources and dam maintenance. Understanding Derna's collapse is essential before drifting into global patterns. This cataclysm set the stage for any discussion on how floods are evolving, from slow, predictable river rises to surging walls of water that leave no time to react. Such was the scenario in Bhutan and northern India earlier this year, when the Tala hydropower dam overflowed after days of torrential monsoon rain. The spillway gates jammed, and a thunderous sheet of water spilled into the Duars region of West Bengal. Indian authorities placed their disaster response force on maximum alert, as footage showed riverbanks crumbling and roads collapsing into the current. In neighboring Darjeeling, a series of landslides killed at least 28 people, and heavy rains exceeding 260 millimeters in 24 hours inundated entire districts. Further east, China faced its own dam crisis in Hunan province, where a section of the Dongting Lake embankment gave way in July 2024. What began as a small seepage hole widened relentlessly. First 10 meters, then 50, then 200. Until a 220-meter breach let water pour into Tuanju County. In a few hours, 48 square kilometers of farmland and homes were underwater. Local officials described it as a race against time, as workers rushed to reinforce the remaining sections with sandbags, while helicopters evacuated over 7,000 residents. Satellite videos and on-site reports showed brown, sediment-laden water rushing through the newly formed gap, dragging away trees, houses, and entire sections of road. Eyewitnesses told Sixth Tone that the sound was like thunder that didn't stop. One elderly resident recalled how the current rose up the walls like it was alive. Not long before, China had faced another record-breaking event at its Three Gorges Dam. During the summer floods of 2020, the reservoir saw an inflow of 75,000 cubic meters per second, the highest ever recorded. To relieve pressure, engineers opened multiple sluice gates, sending torrents down the Yangtze River basin. Though the dam withstood the strain, hydrologists warned that such extreme inflows, driven by climate intensification, may become the new norm. In Texas, the 2025 Central Texas floods reminded the world that even regions with advanced warning systems can be overwhelmed. Over the course of a single night in July, flash floods tore through the Guadalupe River Valley, raising water levels beyond the highest marks ever recorded. Within 45 minutes, the river's surface rose by more than 5 meters. Cars were overturned, bridges washed away, and more than 130 people lost their lives. Analysts estimated damages exceeding $1.1 billion. Climate scientists from the National Center for Atmospheric Research, NCAR, note that flash flood frequency in mid-latitude regions has increased by 20% over the last 2 decades, largely due to warmer air's ability to hold more moisture. Every degree Celsius means roughly 7% more water vapor in the atmosphere, explained Dr. Elisa Tran, a hydrometeorologist. That's fuel for more extreme rainfall events, and when the terrain or infrastructure fails, the water has nowhere to go but down. Historical records affirm that the worst disasters often combine engineering vulnerability with climatic extremes. In Norway's Gjerdrum landslide, 2020, heavy rainfall loosened quick clay, sending entire houses sliding into a valley in seconds. In Pakistan, footage from the Hunza Valley landslide, 2022, showed a massive rock and mud collapse plunging into a lake, sending shockwaves that capsized boats and destroyed villages downstream. The scenes are painfully similar. A roar like an approaching train, the ground trembling, then a wall of water and mud surging through streets that minutes before were ordinary neighborhoods. Survivors often describe a chilling silence after the noise, only the sound of dripping and distant cries. A world of floods. From Japan's Kyushu floods in 2020 to Pakistan's historic deluge in 2022 that affected 33 million people, extreme floods are now a near-annual phenomenon. In Kyushu, over 1,000 millimeters of rain fell in just 2 days, once-in-a-century levels, causing rivers to breach and 68 people to perish. In Pakistan, the Indus River overflowed its banks across a third of the country, submerging villages and farmlands. UN Secretary-General Antonio Guterres called it climate carnage. There was no sky, only water, one farmer from Sindh province told Al Jazeera. The river had swallowed our homes. Across the Philippines, Typhoon Haiyan, 2013, remains seared into memory. Storm surges up to 6 meters high killed more than 6,000 people. In Indonesia, 2021, torrential rains triggered mudslides that erased dozens of mountain settlements. Even Norway, known for its cool stability, suffered tragedy when a massive landslide struck Gjerdrum in 2020, swallowing homes under liquefied clay. A reminder that geology itself can turn against human settlements. The human toll. The human face of these floods often appears in the same way. Families on rooftops, waving for rescue helicopters, children clinging to debris, and cities cut off by brown, swirling torrents. Beyond the immediate deaths, floods leave behind disease, displacement, and economic paralysis. The World Bank estimates that flood-related damage costs the world more than $250 billion annually, a figure likely to triple by 2050 without adaptation. In South Asia alone, up to 700 million people now live in flood-prone zones. Psychologists and relief agencies also note a rise in what's now termed climate trauma, post-disaster anxiety, survivor's guilt, and chronic displacement stress, particularly in children. Warning signs ignored. In almost every modern flood disaster, investigations reveal that warnings existed but were either delayed, ignored, or insufficiently communicated. In Derna, engineers had warned for years about cracks in the dam walls. In Pakistan, satellite data had already shown the river swelling beyond historical thresholds days before the floods struck. In the Philippines, coastal evacuation drills had been planned, but insufficient shelters existed for the numbers at risk. Technology is no longer the barrier. said Dr. Hannah Cloak, a hydrologist at the University of Reading. The barrier is governance, turning forecasts into action. Lessons from the water. After each catastrophe, reports pile up, pledges are made, and funds are announced. Yet recovery remains uneven. Wealthier nations rebuild with modernized levees and early warning networks. Poorer regions rely on humanitarian aid and hope. Still, innovation is emerging. AI-driven flood prediction systems, satellite-based rainfall nowcasting, and mobile-based evacuation alerts are transforming how warnings reach people. However, experts warn that these systems can only mitigate, not eliminate, the threat if urbanization continues to push into floodplains. The planet is not flooding more often because it hates us, wrote climatologist Dr. Friederike Otto of Imperial College London. It's flooding more often because we've built our lives where the water wants to go. The floods of October 2025, northern Vietnam. By early October 2025, relentless monsoon rains had lashed northern Vietnam, triggering the region's worst floods in a decade. Over 3 days, parts of Lao Cai,Ien Bai, and Ha Giang recorded over 600 millimeters of rainfall, roughly equivalent to 3 months' rain falling in 72 hours. At dawn on October 7th, a local hydroelectric dam in Yen Bai province began overtopping. Within hours, emergency sirens blared across valleys, but many residents were trapped as landslides blocked the escape routes. "We woke up, and the water was already at our door," said one survivor, speaking to Vietnam News Agency. "By the time we ran to the roof, it was too late for the neighbors." According to the Vietnamese Ministry of Natural Resources and Environment, the floods killed at least 118 people and left nearly 200 missing. Entire communes were submerged, highways collapsed, and thousands of homes were destroyed. The Red Cross described it as a humanitarian crisis unfolding in real time. Satellite imagery from the European Space Agency's Sentinel-2 confirmed widespread inundation, while hydrologists noted that soil saturation levels had already been extreme due to prior typhoons. The combined effect produced what meteorologists called a compound disaster: simultaneous flooding and landslides. Scientists attributed the event partly to record sea surface temperatures in the South China Sea, which fueled intense convection, and to land degradation caused by deforestation in northern hills. "This is no longer just weather," said Dr. Nguyen Thanh Son of Hanoi University of Science. "This is the new normal of a changing climate." Long after the floodwaters recede, what remains is not only destruction, but memory of how swiftly stability can dissolve into chaos. In every place struck by such disasters, survivors speak of the same silence after the storm, the same disbelief that the ground beneath them could betray its calm. The physics of a dam failure may be calculable, yet the human cost never is. In Derna, months after Storm Daniel, rescue workers still uncover fragments of homes buried in sediment, furniture twisted around rebar, children's shoes half buried in silt. The city's riverbed, once a dry wadi, is now a scar visible from orbit. Engineers from Turkey and Italy have been assessing the remnants of the upper and lower dams, concluding that years of deferred maintenance, combined with the force of an unprecedented storm, made failure inevitable. A Libyan hydrologist, speaking to Reuters, called it a disaster 40 years in the making. In Lai Chau, northern Vietnam, where the small hydropower dam breached in October 2025, rebuilding begins even before the land dries. Soldiers wade through thick brown water to clear roads. Villagers, many of them farmers, salvage rice sacks that have turned to pulp. In one valley, the local school stands half collapsed, its roof sheared off. The head teacher told reporters that he plans to reopen classes under any roof we can find. His voice carried the weary pragmatism of someone who knows the rains will come again. These stories, repeated across continents, are reminders of what climate scientists have warned for decades: that hydrological extremes are intensifying, and that our built infrastructure, dams, levees, spillways, was largely designed for a gentler world. The Intergovernmental Panel on Climate Change, IPCC, estimates that for every 1 degree Celsius increase in global temperature, the intensity of extreme rainfall events can rise by 7 to 15%. That may sound abstract until you watch a river climb its banks faster than you can climb a staircase. Yet the challenge is not only physical, it is institutional. How societies plan, warn, and respond. In Derna, emergency alerts came too late. Mobile networks failed as power lines fell. In India's Duars region, the sudden release from the Tala Dam caught entire villages off guard, despite satellite tracking of rainfall. In Hunan, China, local officials issued 3 separate warnings before the Dongting breach, but residents later said they didn't understand what level 3 really meant. Communication, as disaster scholars point out, is often the weakest link in the chain of prevention. After each flood, the conversation turns to accountability. Could it have been prevented? Could the dam have held? Could more lives have been saved? But beneath those questions lies a deeper one. What does resilience look like in a world of accelerating water? In Norway, engineers have begun remapping susceptibility zones, integrating real-time precipitation data with AI-driven terrain models to forecast potential landslide triggers. In Japan, new early warning systems now estimate the rate of slope saturation, not just rainfall totals, to predict flash floods before they form. Vietnam's own Ministry of Natural Resources and Environment recently launched a pilot River Guardian network, installing automatic flow sensors in 200 northern rivers to detect sudden upstream surges. These innovations represent progress, but they also underscore the truth that adaptation is reactive. We are learning as the floods teach us, one disaster at a time. The economic cost, meanwhile, mounts silently. The World Bank estimates that annual flood losses globally have tripled since 1980, now exceeding $60 billion per year. But the hidden toll is on displaced families, lost farmland, and the erosion of community itself. In Gansu, western China, where landslides buried entire hamlets after torrential rain, villagers speak of returning, not to rebuild, but to remember. In Pakistan's northern valleys, farmers have begun planting higher up the slopes, even as they know erosion will follow. The land adjusts, painfully, unevenly, to new rhythms of water. For scientists, these events are not isolated. They form a pattern, one that reveals a planet entering a new hydrological age. In this age, floodplains redraw themselves, glaciers melt into rivers that were once seasonal, and aquifers swell or dry unpredictably. Even the largest reservoirs, once symbols of mastery over nature, are being tested by forces beyond their design parameters. We built for the 20th century, says Dr. Layla Ahmed, a civil engineer at the University of Cairo. But the 21st has already changed the rules.